Welcome. Today we are going to learn about absolute value equations and inequalities. And actually this first session we're only going to do absolute value equations. So we're going to call this day 1. And before we start, we want to review what absolute value means. Absolute value is how far a number is from 0. So if you think about, if you see something like the absolute value of x equals 5, well, if you think about where 5 is or 0 is on the number line, and you have 5 and negative 5, you will notice that they both are the same distance from 0, which means that x could be 5 or negative 5. So with that being said, a lot of your equations are going to have 2 solutions. And so it's very important that you check to make sure it makes the original equation true. So let's start with the first example. Okay, we have the absolute value of 2x minus 1 equals 5. The first thing you want to do is make sure you isolate the absolute value. That means get the absolute value by itself. And if you notice on the left side, the absolute value is by itself. So you're going to rewrite your equation like this. And you will distribute the positive and the negative so you can have 2 possible equations. So if we distribute the positive, we would get 2x minus 1 equals 5. Or if we did the negative, we would get this. Make sure you distribute the negative to both. So then you're going to solve both equations. So on the left side, you'll get x equals 3, or and then x equals negative 2. So if you go back and check, using the 3, 2 times 3 is 6, 6 minus 1 is 5, absolute value is 5. And then if you check negative 2, 2 times negative 2 is negative 4, negative 4 minus 1 is negative 5, absolute value of negative 5 is 5. So in this case, they both work. And if they ask you to graph the solution, instead of you shading, it'll actually look like this. 3 was a solution, and negative 2 was a solution. Those are the only 2 solutions in this case. So that's how the graph would look. And now I want you to okay, so you can pause the video, see if you can get the right answer, and we'll check back together. Okay, this is what you should have gotten. Making sure that the absolute value is isolated. And remember, we have plus and minus to form our 2 equations. So on the left side, we ended up getting 2/3, and if you plug it in, 3 times 2/3 plus 2 equals 4. Or 3 times negative 2 plus 2 equals 4. And let's see, these cancel. So you're left with the absolute value of 2 plus 2, which is 4. Absolute value of 4 is 4, so that works. And over here we get negative 6 plus 2 equals 4. Absolute value of negative 4 is 4, and that one works. So those are your two solutions for that one. Okay, let's try a multi-step absolute value equation. So as I stated before, you want to get or isolate the absolute value. So if you notice, on the left side, the absolute value is not by itself. So first thing you want to do is add 1. And then you want to get rid of that 3, so you can divide both sides by 3. Now we can set up our equation and distributing first the positive, and then we got to distribute that negative. So over here we would get x equals negative 5. And over here we get x equals 1. So you always want to make sure you go back and check your answers. So if you plug in 1, that one works. And if you plug in negative 5, that one works as well. And if they ask you to graph the solution, since those are the only two solutions, and we will mark negative 5 and 1 as our solution. Okay, then you can try this one. There. Okay. So, after isolating the variable, you're able to set up your two equations. And then on the left side, you get x equals negative 7. On the right side, x equals negative 11. And always make sure you go back and check your answer. You don't have to show the step, but make sure you do check. And in this case, both solutions work. And if they ask you to graph, we have negative 11, negative 7, and they are both included. Now, we'll try a different problem. Because so far, everything's been checking out. Okay. The left side is already isolated. So you're ready to set up your equation. And you only do the side that has the absolute value. So distributing the positive, we get this equation. Or always rewrite this so you can understand when I'm at the step of distributing. So getting the x's on one side, I'm going to subtract the 4x and then subtract the 2 on the other side. and get x equals -3. Or, I'm going to distribute the negative. Make sure you distribute it to both. And subtracting 4x now gives me -7x. And adding 2 gives me 7, so x equals -1. Alright, so let's first check -3. And you have to plug in -3 on both sides, because they both have an x. And over here we get -9 plus 2. All of that is in absolute value. And -12 plus 5. Now over here, -9 plus 2 is -7. But the absolute value of -7 is 7. On the right side, you're just going to have -12 plus 5, which is -7. So if you see, one side is +7, one is negative, that one's not going to work. On the right side, we're going to plug in -1. And you get -3 plus 2 and -4 plus 5. On the right side, you get a +1. On the left side, you get the absolute value of -1, which is +1. This one works. So this one will only have one solution. So it's very important that you check. So x equals -3 is what we call an extraneous solution. That means that we got x equals -3 from the original equation, but it's not a solution to the original equation. All right, we're going to try this. Got it? Okay, and don't forget to check your solution. Okay, so the absolute value was already isolated, so you can go ahead and set up your two equations. And on the left side, I got x equals -8. And on the right side, I got x equals -1. Now, plugging in -8, what's going to happen is you're going to end up with this. So on the left side, you're going to end up with +42. But on the right side, we get -42. So that one is not going to work. Then on the right side, we're going to plug in -1. So we get +7 on the left and +7 on the right. They both work. So our only solution is x equals -1. So we're going to stop right here with just the absolute value equations, and we will pick up absolute value inequalities on the next session.